Yeah, okay. So, yeah, thanks for this introduction. Just to put this in context, we didn't have a dedicated slot for the MPI library, so we wanted to very briefly cover the features as part of this overview of the One API HPC toolkit. And what is new here for the Intel MPI library is GPU awareness, and that is twofold. So on the one hand, we do support already GPU buffers, meaning you can pass any pointer to GPU memory to an MPI library call, and that will automatically manage it for you and do the copy itself. And that will do it in a buffered approach as well. If you have, for example, a large pointer, a pointer to large device memory. In addition, we'll have GPU pinning support here that will allow you to pin specific ranks to specific GPUs or tiles. And that is useful if you do offloading to these GPUs from that ranks. And that will help you not just to scale out to multiple nodes, but it will also help you to scale up within a single node. So if you have a GPU, and Igor's going to talk about it later, very likely, it could be in the future that it has multiple tiles and you program for a single tile or you program for multiple tiles, but it is the simplest approach to program for a single GPU tile. And if you have an MPI application, you could scale even within that single machine or node by using the MPI library and therefore addressing multiple tiles by multiple ranks offloading simultaneously to this. And therefore, the MPI library can also help you to program for larger GPUs. And on the next slide, Edmund, we'll have a very brief summary of how this GPU buffer support works. So don't worry about this Openmp statements here. We're going to cover these in more detail tomorrow. More important is that the MPI send statement on the bottom is really just an MPI send as from the MPI standard. Even though it points to GPU memory here and in the values pointer, the MPI library will transparently handle that for you once this is enabled. And if you enable this environment variable here displayed on top, the MPI library will do an additional check where this pointer actually points to and initiate a copy operation if necessary. And on the next slide, Edmund, this is a very brief example how this GPU pinning works. So in this case here, on this pictures on the right-hand side, you have two different scenarios. On one scenario on the top, you have a dual socket or dual NUMA node machine where you have two GPUs. One is connected per NUMA domain, and then you spawn 4 ranks on this. And on the bottom, you only spawn 3 ranks. And per default, if your GPU has, for example, multiple tiles, like in this case, 2 tiles displayed here, you could define with the environment settings of the MPI library how you want to spread your offload regions of different ranks into different GPUs and tiles. So you can define a granularity here as this offload cell is a tile right now, could also be a whole device. And then you have a domain size and so on. These are all default settings, so you don't need to worry about this. But the interesting thing is the MPI library can help you to distribute or do your decomposition even within a node, not just across multiple nodes. And that's where it helps you, and you can even display some debug environment in order to see which ranks are pinned to which GPUs and therefore can offload to the specific GPUs or tiles. And with this, I think we can close this first session, Edmund, if there are no questions, and move to the DevCloud. Okay, I hope you can see my screen.
Yes.
Okay, I'll skip most of the slides in the interest of time since we're a little bit behind here and focus just on the last slide and then do a little bit of a demo. So what is the Intel DevCloud meant for? It's twofold. On the one hand side, it's for you a sandbox to try out the implementation of our One API toolkits across the board on Intel hardware. And there you also have discrete Intel GPUs available, which are from the consumer segment, so they are not data center class GPUs, except if you have an NDA with Intel and you can get a hands-on an NDA account, then you can also try out some of the more data center class type of GPUs, which are still pre-production vehicles to keep in mind. And this is the equipment you have right now. So there's some Xeon processors, some clients or i9 processors with integrated GPUs. You have some of this Iris Xe Max GPUs. So these are discrete GPUs. And you have some FPGAs within Stratix 10, ARIA 10. You have some FPGA emulation and so on. So you basically have all the different hardware components that are supported and can try out these. Also, you have all the toolkits, as I mentioned, already installed. So you don't need to install anything. You just log in and get started. And this offering is free of charge. And you get, I think, per default, a 3 months account or 6 months account. And you can try all of these out without the need to install anything on your systems, without the need to have hardware in your labs. And without further ado, let me show you how the registration works. So you can relatively easy Google this address. So there's the get access method for the DevCloud. Do you have a little bit of some forms to fill: name, email address, country, region, what you're interested in, what particular hardware, what type of developer you are. You click on submit, and then a couple of minutes later, you have an email in your inbox that shows your registration link, and then you have an account. So it's pretty straightforward, and I would like to motivate you. Maybe I can spare a little bit time as part of the session if I'm finishing quicker, or if not in the break, maybe motivate you to create an account. This will allow you to also follow some of our hands-on examples, because a lot of examples we are going to show are actually based on some examples that are already on the DevCloud. So what I actually forgot to mention is not just good to get started with the hardware and software package. There's a lot of trainings already on the DevCloud to get you started on learning DPC++ or Openmp offloading there as well. Okay. So let me close that and show you how it looks like once you're logged in. I'm now logged in with my account. You see that's my username, my account. You have your expiration date on the top right, and I hope the screen is large enough that you can actually read what I'm showing, or the font is large enough. And then you see this is the expiration date for your accounts. You have some announcements. For example, here this Iris Xe Max GPU is available. To all people, here's the different offerings. There's a little bit of an introduction video. There's a little bit of information how you can actually log in, how this login works, but I'll show you in a minute, and the different components installed on that, right? But before we move on, Thomas, can you please, run the poll question on the DevCloud? Okay, I was mostly interested in the one on the first one, but all the poll questions here are interesting. So please run these. So the question is: have you used the DevCloud before? And as expected, most people have not used, but I see it's about 1/3. I can see right now, or 1/5 who already have experience there. Okay, so now let me show you a little bit on this get started here. If I click on this get started link, it will show me the different options I have once it's loaded. So I have these different toolkits that Edmund talked about. And if I just click on this first link here on this get started with first example, it shows me first how I can connect to the DevCloud, right? And we have here instructions for Cycwin users on Windows, or we can directly jump to the SSH step, which is then mostly interesting for Linux users. This is some predefined instructions how you can set up this access, or you directly download your SSH key, where you have some instructions how to set it up, right, and how to enable your SSH connection to the DevCloud. And it also fills in your specific user in here, so it makes it much easier to run that. And even if you're behind an SSH proxy, like it is in my case, it shows you how to connect to the DevCloud. So it's pretty straightforward and it's very nice explained. And once you have set up your connection, you can then connect to the DevCloud and then clone, for example, one of these Git repositories with one API examples and start working on the console. So let me show you on the console how this looks like. And again, I hope the font size here is large enough that you can actually see that. So I'm now logged into the DevCloud with my user. Let me make it a bit larger even. So Now, for example, I can check what kind of resources are available. So this is actually an HPC system from the way it is set up with a batch system. But even if you're not familiar with a batch system, I'll show you in a second how you can get along the system without any of this. Oops. And here you see we have systems with some high-end client processors with an integrated GPU. Sorry, this is the one with an integrated GPU Gen 9 here. These are the ones with these dedicated GPUs. And there's even some with multiple dedicated GPUs available. You have some nodes with FPGAs and so on. So all these kind of resources are available here. And if you want to know what resources you currently have allocated, you just run qstat, for example. By the way, this is all documented as part of the DevCloud introduction material that you find on the web pages, so no need to take any notes here. And if you're not familiar with how to submit a job on such a system, you can simply create a new script. It's on my script. And just run hostname. And then, since the OneAPI HPC toolkit environment is already loaded, you can use some of the commands coming from OneAPI. So we have a very useful cycle -ls -verbose, and that would show all devices that are available as part of this node. And now I can just submit that particular script. Again, if you're not familiar with this job submission, don't worry, I'll show you an alternative in just a minute. It's just for those people who want to use the command line and do things manually. And all of these instructions are part of the reference, so you don't need to take any notes. In the local directory, I want to execute my script, and now it is submitted against the batch system on any of the 3 nodes. And in a couple of seconds, likely I will have my output files of this run of my script. There they are. So I can, for example, have a look at this output, and then we see a specific node that it was running on. So this was the specific node, and now you could check with PBS nodes what the sources are available. But you see there's an FPGA emulation device available. Here you have the platform number 2. So this is from a circle perspective, the different platforms. You have the OpenCL runtime for the host, so for the processor. Then you have one platform, which is the OpenCL implementation for 2 devices. So this is a multiple device system. It has 2 dedicated GPUs from the same kind, and that's why they appear twice here. Then you have the level 0 implementation, and Igor is going to talk about that in a minute. What is this? This is an alternative to OpenCL, where you have the same devices listed as well. And then we have the Circle host platform, which is a serial, mostly for debugging purposes platform. And you see all of these default selectors are available here. Okay? And as an alternative, you can also, instead of submitting a job script, you can launch an interactive job like this, and then you're directly on such a node. And then, for example, I check with qstat what's happening. Then I see I have one job, and that's the one that I'm currently logged into, which is active and running. And that is the job logged into this specific node here. And as you can see from the environment, so let me copy this, makes it quicker than typing it. From the path, you can see that the OneAPI environment is already loaded. So all the tools are already in the proper paths, and therefore you could directly get started working on this. And that's the reason why this cycle -ls was working, because it's coming out of our OneAPI compiler environments, right? And I could now run this as well here again.
There is a question in the chat. Does SYCL -ls give the subset device information of seal info?
Not that I'm aware of. Igor might know more in this case.
Yeah, it's not a subset, it's even more than CL info. So it is exactly what CL info usually provide you in the output. Plus, it also lists level 0 devices, which CL info simply cannot see just because it's only OpenCL related stuff. But yeah, in SYCL-ls, you can pass -- verbose option, and in that case, the output, even the output, will look quite similar to CL info. And if you're looking for some more debug information about how many tiles you have, how many execution units, and so on, we have a special tool you can get, open source to compile and run. I can go into more details later.
Yeah, so we will cover that in a bit. And the alternative, so for those folks who are not familiar with running on this job submission scripts, if you get on this, get back on this, get started, and just to show you how it works, on my command line interface, I'm showing a queue stat. So I'm listing all my jobs and I'm updating it every second. And on the very bottom, there's the alternative. It's called the Jupyter Hub or the Jupyter Lab. And if I click on that, this would allow me to try out one API while staying completely in my browser. So I don't even need any command line interface. I don't need to be familiar with all this job submission and so on. And you see at the same time, it's actually launching a job against this queue as my user while starting this Jupyter Hub. And for those of you who are familiar with Jupyter, it's kind of an interactive Python shell. But here, as part of the DevCloud, it has been used or kind of extended to allow job submission through it and therefore allow it to do everything via the browser, via this Jupyter Lab. And also very interesting to note, there's plenty of labs already on this Jupyter Hub. So in my specific case, obviously there's more here. There's some more folders I created, but there's, for example, an one API Essentials lab and so on that you can get started with and learn data path C++. There's an Openmp Offload. So let me launch one of them just to show you how it looks like. There's a lab for Openmp Offload. Then you want to start with module Fortran, Openmp Offload. It launches this Jupyter Hub, and then you have your simple cells to execute like in a known already from the Python environment for some of you. And it writes these Jupyter cells to a file, and then you have your compiler calls and so on. So it basically is also used in our case here to run batch jobs, right? So using, for example, this bash integrated shell that you can use here. So it's very straightforward. There's even a welcome script that shows you how to use this and how the job scripts are actually created. And it submits an hello world example against the job system. So again, you don't need to know any of these commands. You can get started with these Jupyter Hubs and learn data part C++ as well as Openmp offloading. And with this, I'd like to close, since we're already a little bit behind time, and open for maybe one or two questions before heading to the break.
Okay, any question? In the meantime, I restart the poll for the presentation, so please vote.
So there's some questions coming in regarding how you show more of this hardware matrix of the GPUs. We have a repository, a public repository, where you can download some of these applications that you can compile, which read such information. I'm not sure if Igor will cover those, but it's not part of the DevCloud introduction here, at least. So
there is a question from Antonio. I already have had a DevCloud. Yeah, okay. Igor answered. His account expired. Can I open a new one for free? And Igor answered, you can extend it for free.
You can extend it, and the other option, yeah, I haven't seen any blocker to register a new one if you want. So you can do this actually, but I would assume that it will be more convenient for you to extend your existing one, because in that case you can get an access to all your files which were stored there, right? And I think we allow up to 200 gigabytes if I'm not wrong. So if you worked on some project on the DevCloud, then it really makes sense to extend the old one.
Yeah, just one more hint. When you're working on the DevCloud and running on these GPUs, keep in mind they are not data center class GPUs. These Iris Xe Max, they are mostly for consumer segments and are meant as enabling devices. And even if you have an NDA account and you can access those data center class GPUs, keep in mind these are pre-production devices. So don't fine-tune performance for any of these specific devices. You should wait for the final data center products before doing that. They are mostly meant as enabling, porting your code, and then trying or validating results.